Okay, today is polynomials day 2, and this is what we did yesterday. We talked about polynomials. We're going to talk a little bit more in depth about them, but a polynomial has 3 requirements to be a polynomial, and I want to just review that with you. So what would disqualify this as being a polynomial? There's actually 2 things that are going to disqualify it. Yes, sir. It has a -3 in the exponent. Keep going. Yep. Can't have an I for a coefficient. Can't have negative powers. What thing did I leave off that I could have made it even more not a polynomial? Put it all over x, because what rule does it break down? It's supposed to be all reals for a domain. Okay, good. So that's the rules for a polynomial. So now let's make a more normal one. Let's say you had 3x to the 5th minus 2x squared plus 4. How about that? Would that polynomial right there have a degree? Good. I'd like you to write down what's its degree, what's its lead term, what is the lead coefficient, which is part of the lead term, what is the behavior on the left end, and all you have to say is up or down, and behavior on the right end. And I actually strongly recommend that you reverse these two and do the behavior at the right end first, because that's the way you should do it. Because you can't really tell the left end until you do the right end. I'll pause while you try that one. So the degree 5. Why? Please don't ever add those powers together. It's already been multiplied out, so you cannot add x to the 5ths and x to the 2nds. They're unlike terms. The lead term is this one, 3x to the 5th, and then the lead coefficient is the 3. The behavior on the left and right end depend on this. If this is positive, which it is, it's up on the right. Notice I started with the right end first. Then I go back and see if the power, the degree, is odd, it will be different. And therefore, this is odd, and therefore it's different. There we go. Raise your hand if you had all of those correct. Okay, good. So I need to now give you a better picture of like what this kind of looks like. So I'm going to make a quick sketch of it. I'd like you to do it with me. Would you agree, since it's going up on the right, that it's going to end going up, and at the beginning it's actually going down? Then we don't know exactly how it touches the x-axis. It might be bouncing, it might be cutting through, it might be snaking. You learned those last year. Do you get that it could be bouncing off of it like this? It could be cutting through it like that. Or it could be doing what's called a snake, where it changes from the one to the other kind. That one's best seen on x to the 3rd, which looks kind of like this. This is the snake through instead of a cut through or a bounce. Remember that guy? At this point, it's this point of inflection, it's called, where it changes from increasing at a decreasing rate to increasing at an increasing rate. They change types of increasing. Harder for me to draw it the other way, where it's going down this way, and then it changes. I'm terrible at that. Where it's going down or decreasing the whole time. But I can do it if I really think it through. Okay, let me think. There we go. Connect up those two, make a bigger dot. That'll fix it. There. Okay. That's still terrible. But anyway, there's 3 different ways that you can touch the x-axis, and that's the main thing we're talking about for today. Would you agree? I'm going to, on purpose, make something wrong with this sketch. What? Oh, actually, I think I might have made it right. Will you tell me, do you think I made the sketch generally right or generally wrong? Okay. So this lead coefficient is positive. That means that ends up. That's good. This ends down. Let me think. odd and therefore different than the other end. Yeah, that's good. But what's the last thing you can check? That. It's the y-intercept, because the y-intercept is where x equals 0. And so I could put in a 0 here and here, and they'd cancel, and so it's 4. And it hit at something positive and small, so yeah, it could have been hitting at 4. All right, so that is a possible graph of this. Now, what are we going to do for today that makes it more complicated? Not that much. We're going to know what the roots are. We're going to know this and this and this. We'll know a little bit more info. How come? Because they're going to show it to us in this form. Imagine for a moment that I asked you to multiply that all the way out. That would probably literally take you 5 minutes to multiply it all the way out. Maybe not 5 minutes. It would take a while, though. Because first you'd have to FOIL this one out. It's not just x squared minus 16. It's first outside, inside, last. And then you'd have to get all of those parts multiplied by x plus 5. You could do it, but all that really matters is the lead term. So can you just do the lead term in your head? Notice the coefficient on there is a 1 in each case, which makes it pretty easy. Y equals 1x squared times x, which makes 1x to the third. Why is the lead coefficient so important? Because it tells you the ends. Can you tell from looking at this that the right end is up? And if the right end is up and this is odd, therefore the left end is down. You get what I mean? I don't need the whole rest of the equation to do that. One other thing I could get from it real quick is the y-intercept is where x is 0. Put in a 0 here, put in a 0 here. What's negative 4 squared? Positive 16 times 5. It's a big number, but it's a big positive number. So if I were to graph this one, I would know its y-intercept is some big positive number. I would know its lead coefficient, which tells both ends. But more importantly, this time, I can also know its roots. What are the roots? The roots are the x-intercepts. The x-intercepts are where y is 0. If I make that equal 0, just for a moment, it'll tell me that 4 is important and negative 5 is important. Those are the two roots. So watch how I can be much more accurate with this kind. I know it hits at positive 4, and I know it hits at negative 5. And I know it bounces. You remember that evens are bounces? It bounces at the 4, but wait, I don't know if it's up or down bounce. How could you tell which one it is? Yes? All right, so the right end is up in this case, true? Because the lead coefficient on this thing was, so it's positive, and therefore it's up. And if it's up here, do you get it can't be a upside down bounce? It has to be a right side up bounce. Okay, and then this one has a power of 1, which means it's a cut through. So that means it just goes straight down through that. And there we go. We got it going up on the right, down on the left. We know our y-intercept is some positive number. In fact, it probably goes way higher than this, but we've got a positive y-intercept at least. That's a sketch of this graph. Let me give you an alternate way you could have done it. If you check where this thing is positive or negative, you could have done the same graph. Like, for instance, we know that 4 and negative 5 are our two important points. Do you remember that thing where you can check intervals? Like, let me check something bigger than 4. Well, let's check something bigger than 4, like 5. And this is important to know. You do not need the exact answer. You just need to know if it's positive, as in up. Do you get that 5 minus 4 is 1 and 5 plus 5 is 10, and 1 squared times 10 is going to be a positive number? So I checked 5, which is in this interval here. It's positive. Do you get how that also could have told me that the right end is going up? That makes sense? Okay. Now, I kind of like the other way of knowing that the right end is up, but the bad thing about the right end and the left end is it doesn't tell you anything about the middle. So the middle I can check by any number that's between -4 and 5, and my favorite one in there is 0. So let me check 0 quick. 0 minus 4 and 0 plus 5. That's -4 squared, which makes it positive 16, and positive 5, it makes positive. So it's positive in this area, as in it's above 0. And the last zone I can check is things that are smaller than -5 over here, like -6. If I stick in a -6, it'll make a negative squared is positive, and this will be a negative. It'll be a positive times a negative makes it negative. There, I just taught you everything that you need to know for this hour, but that was a lot all at once. So what I did at the end is what's called a sign chart. In this zone, from here to here, it's negative. From here to here, it was positive. And from here to here, it was positive. What I think would be best is if we could start with something simple like this. And I would like you to make a sketch of it. I would be thinking, oh, the lead coefficient is x to the what? And that tells you, since there's a 1 here and a 1 here, that tells you both ends. You also know where it hits, wherever they are. And then you can make a sign chart, or you can just sketch it and go, well, I think it has to go like that. Which, by the way, is totally wrong. But anyway. All right. Make your best sketch of this. I will pause for a second while you give that a try. Okay, so here's what you should have been thinking. Since this is 1x to the 6th is the lead coefficient, it must be up on the right, and it must be also up on the left. Raise your hand if yours did that. Good. Then it has to hit at +2 and -3. Those are called the roots, the x-intercepts. So here's +2, and here's -3. And here, it must be, what does a power of 4 look like? Well, that's a bounce. Any even number is a bounce. Okay, so it's bouncing here. Do I know if it's this way bounce or that way bounce? Is it A or is it B? It's A because it's going up on the right. B wouldn't be going up on the right. So it has to be like that way. And then it also is bouncing here. How can it do that? Oh, bounce and go back up again. There we go. Does it have a local minimum? How many local minimums does it have? 2. Does it have an absolute minimum? Yes, 2 of them. They're both absolute minimums and they're both local minimums. That's a little weird. But they are those 2 spots are the lowest of them all, and they're tied. So list them both. All right, next thing. I did not ask you to do this, but if I was going to do this from a sign chart perspective, in the middle, it's positive. What if I asked you to prove that to me? Like, let's say I had mine going down in the middle. To prove that is wrong, take a point, good, from between here and here, which would, like, what's a good one? 0. 0 is a great one. So I put in 0, and I would get -2 squared is 4, and 3 to the 4th is some huge number, and they're both positive. So it's got to be positive. Oh, 324. Good. But either way, it's positive. It's positive in there. It has to be above 0. Okay, so, yay, I did that right. And then this must be positive, and this must be positive. But if all we knew was positive, 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 one thing we could do to kind of check ourselves would be the Y-intercept. The Y-intercept is where what? X is 0, and if you put in a 0, it sounds like somebody's already calculated it was like 300 and something. So, thank you. So then you go down through here, up way, way, way up there, and then come back and then bounce again off of that spot. So, okay. So the only thing off of my blue sketch is that it probably should go a lot higher than it is. Okay. So, one more like that. Let's see if you can do this one, I'm going to throw in a twist. It's not two bounces. It's not a bounce and a cut through. It's a bounce and a snake. And I threw in a -2 in the front of the whole thing. And that should tell you something. So figure out your lead coefficient and your lead term, and you'll know how the story ends and how the story begins. In the middle, you'll find out what the middle of the story is. You'll find your roots. Okay, make your best sketch of that one. I'm going to pause and give that a try. This is the main new thing for today. Okay, let's see how you did on this one. I hope you had it hit at 3. And I hope you had it hit at -5. If you got nothing else right, those 2 points should be right. They're the what's? Roots, x-intercepts. Okay. And next, my lead coefficient, I'm only multiplying out this part, this part, this part, and I got to put it to a power. It's going to be -2x to the 5th. Now I know that it's negative up front, which means it's down on the right, and it's odd, which means they have to be going opposite directions, so up on the left. So I could take a shot at this and just say, okay, go through here, bounce, and then come down. I did the correct ups and downs, but I didn't do the correct roots, did I? Okay, let's check what we should have done. We should have bounced. The 2 is a bounce. The bounce is at -5. Bounce is here. Positive y-intercept cutting through that one. True or false? False. Not supposed to be cutting through that one. What's this 3 mean? Snake. And that's the kind that's my kryptonite. So I'm going to say, there, close enough. The decreasing bounce. Even after teaching math for many years. Yes. Well known to taking down several math teachers. Okay, anyway, that is your graph. That's your sketch. What didn't I make? I didn't check any signs. A sign chart would be a way to make sure I didn't screw up. So let's just check in the middle zone, because I'm pretty confident my ends. But let's just check in there and make sure. Would you check a value, any value? Pick any value right now and check it. Stick the number in and see what you get. 0 is kind of a good one because then you're getting the y-intercept. Okay. So you stick in 0 and get -2 times 5 squared. 5 squared is 25. So things to -50. -50 times -3 to the third makes -27. If you didn't even know what it was, at least you knew it was negative, right? And it's a negative times a negative, so that makes it positive. And therefore, it should be positive in this zone. Is it above 0? Yes, and therefore I did it right. Okay, and if you wanted to check all the zones, this one would be something bigger than 3, like 4, and you go, oh, it comes out positive, positive. No, wait a minute. Yeah, positive, positive, and then a negative up front makes it positive, and a negative and a negative. Sorry, 2 positives and 1 negative makes negative, and therefore it's negative in this zone, and it was positive in the zone way to the left, and that's a way you can tell you're doing them right. That's called a sign chart. All right, the only thing I haven't taught you is the proper way to describe this function as being going up on the right. There is an official way to say that, and you need to learn it. It's one of the big 4 things from calculus. It's called a limit. And so instead of just saying it goes up on the right, a mathematician would say that this function, as x goes to infinity has a limit of infinity. Now it sounds really complicated, and let me show you. The limit of this function as x goes to infinity is infinity. If I go infinitely far this way, and then look where the function is, do you get it will be infinitely high? That's what that's saying. How about this? What part of this is telling you we're talking about the right side of the function? What part of it tells you that? Yes. X goes to infinity. X goes to infinity means these x's are getting bigger, 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 bigger. So it means telling you go way to the right. What if I change my limit on the other side to be the limit of the function as x goes to, what do you think I'm going to say? Negative infinity. Then it's saying if you go way this way, then what will the function's value be? It'll be really, really small. If I go infinitely this way, it's going to be infinitely down there. So therefore, it's negative infinity. All right, I'm going to give you one like that. Everybody take this picture and tell me what the right end limit is. The right end limit. This would be like the simplest question on an AP Calc test. What is the right end limit? Let's say it's the limit of the function. How many of you included f of x? Good. As x approaches infinity, that's telling you we're going to the right because that's where the positive x's are. If you go infinitely this way, it's like, what is the y value when I get there? When I go way, way, way this way, it's going to be way, way, way that way, negative infinity. Notice, this is the x value, and this is the y value. Sometimes that helps people to understand the limits are actually the y value. This is just telling you whether you're on the right or left side, or what you're approaching. You're going to get a much deeper understanding of limits as you go to calculus. This is just intro. All right, here's one that's trickier. Remember this function? It's the 1 over x function. And there's asymptotes here that it'll never cross. So my question is, what is the limit of this function as x approaches infinity? Don't say it, write it. What is the limit of this function? If I go infinitely far to the right, what will it be infinitely close to? Pause, we try that one. Limit of the function as x approaches infinity is 0, but all the other answers we gave were infinities. Explain to me why you think that's right. Why don't you think it actually crosses over and keeps going down to like negative infinity? Because it's an asymptote. Very good. Okay, so you are right. It's infinitely close to 0. How would you write the left end limit, Mr. N? Just first, I got to tell where x is. Negative infinity. Perfect. That shows you're on the left end. Is this 0. This is rising ever so slightly, getting closer and closer and closer to the asymptote, but it'll never hit it, so it's infinitely close to 0. And again, I get that it isn't 0, but do you get we aren't really ever going to get to negative infinity? It's the idea. They're both getting like, as we get closer to this, it'll get closer to that. That's kind of what these mean. Because it will never hit 0. We're implying it does, but that's the way these are. These are meant to be the limit as it gets infinitely close to this will be at infinitely close to that. Okay, so One last problem to kind of pull it all together, and it's going to be the first one of your homework. So everybody, see if you can find this one in your homework. Oh, I want to mention just briefly this intermediate value theorem. Do you get, if you're going to get from this point to this point, that you'd have to cross the line to get there? Yeah. So that creates those roots. And how it gets there is what we're talking about today. But there's a special thing called the intermediate value theorem you're going to use heavily in calculus that is your way of knowing for sure that it hits, is this theorem has been proven to be true. All right, moving on. Here's your first homework problem right there. We are doing 13, 17, and 18. Those are the three that are the most important and most like what we just learned for that's new. Then, let's go through and just show you which ones to skip. You're going to get to this one, and you are going to do it. I have given you a lot of like general statements, like you can factor it. You should. If you can't factor it, quadratic formula. Okay, well this kind, you can't use a quadratic formula on because it's going to have an x to the like fourth in it. How do I know that? Because you're going to want to, I've given you another thing about fraction problems. What did I say about them? Clear the denominator. How do I get the denominator out of this? Multiplying by x does not do it. Multiplying by x squared would do it. To get y, that would be smart. Gets the denominator out of there. And this one, it's really obvious because x squared and x squared are canceled. But what happens here? How do I know the denominator goes away? Because one of the x's will cancel, right? And why is this a good thing? Because now it looks exactly like one of your problems, except it's got an equal sign in the middle of it. So you want to set it so that you'll have it all set equal to 0 like this. And if you can factor it, you should. So I don't know, some of you guys might be able to factor it, some of you won't. But if nothing else, it would be an equation that would kind of look like this. That kind of thing. And that's exactly what you've just been doing today. You'd be able to sketch it, etc. All right, so that's the hint for that one, and you are doing that one. These two are skips because if you are going to do this, you're going to have to be able to do synthetic and division. And do you remember synthetic? It's this thing. You drop this, and then you multiply and all that. You did that last year, but I don't think you remember it. So I'm going to show you how to do that, but not today. Too much in today's lesson to do that. So we're going to skip those for now. This one I was going to have you do, but it gets so intense in here that this is not a 3-minute question. It's probably a 15-minute question. It'll make it homework a little too long. So all I would ask you to do is go back to find a cubic regression. It's a lot like a linear regression. Just do a cubic regression on this problem. You just had a test that used linear regression as linreg. Take a wild guess what the other one's called. Cubreg. All right, so do a cubic regression on this, and I think you'll find how the data will match up with that better. All right, let me look at it now. And now that I think about it, I'm not sure this is actually cubic regression data. It might be quartic. So you know what? We're going to skip 34. Forget that. Skip 34. It's cubic or quartic, and I'm just now thinking it's probably quartic, and that makes it, just pushes me over the edge. A little too complicated. This one, definitely should do it. Do you remember doing the box problem with me on Friday, where it was like the length wasn't just the length, it was length minus 2x, that kind of thing? Well, this is about the length plus the girth has to be less than or equal to 130. That's actually like requirements for the U.S. Postal Service. So basically, they can't do it if the box is too big. The trucks can't hold it. You get what I'm saying? They drive the little post office truck around. It can't hold gigantor boxes in there. Okay, so they say if you keep it to this size, you'll be okay. You can set up one of those equations for this. That's a lot like the other one we did. It's kind of like this, except it's not a volume. You have to figure it out. That's your only stretch problem for today. And you need something that's going to challenge you. The other ones shouldn't be super challenging. All right. This one, number 13. I think I've taught you enough to be able to totally do this one. Everybody take a shot at this one. I'm going to pause for a second while you try it, and then I will tell you if you're doing it right. Okay, I'll check that first one for you. Should have been thinking 2 and -1 are the roots. Please take a moment and check this. Stop what you're doing. All right. Now it's got a negative up front, so my lead coefficient's -2x to the third. So it's going down on the right and up on the left. So then that leaves me with, if it's bouncing here, must be a bounce there and a cut through there. There we go. Raise your hand if you had that sketch right. Okay, good. Then it says a sign chart. Along with a sign chart, so at least I would strongly recommend checking on interval and making sure you didn't mess it up. So I'm going to check the interval in the middle because I'm pretty confident on my n values. So I'm going to check in this interval and make sure it's really negative because that's where the graph is below 0. So I'm going to check the number 0. If I put in 0, I now have -2 times 4 times 1. That makes -8. That matches up with my negative. It's negative in this zone. And it's also negative over here, and it's also positive in this zone. So if those are the 3 zones you would check for the sign chart. All right, so that's checking the first one. Gives you a feeling for if you're doing it right. 17 and 18 should follow along pretty normally. This one, you have to do a little bit of heavy math first, but then I recommend setting it all equal to 0 and then see if you can factor it. Because once it's factored, then you'd know what the roots are, and the solutions are what makes it equal 0. So get it all moved to one side. Maybe once you get it all multiplied out, move all this chunk over here and see what you have for a lead coefficient and all that stuff. If you can factor it, you should. All right, these 2 are skips, and then, yeah, I had to skip that one also. This one's really important. Oh, and I did notice one more thing. Everybody on 33, you may skip part C. We're going to not add this. It doubles the length of the problem. You may skip part C there. Just do A and B on 33. Okay, that's all I got for you.